All right, this is workbook page 56. Question number 1 says, name a pair of corresponding angles. Remember that corresponding angles, they are congruent, so they do match in size and in shape, but they also have to take that a step further. They also have to have orientation. So that would mean that a pair of corresponding angles would not only be the same size and shape, but they would be turned in the same direction. Basically, they're facing the same way, so they have matching orientation. An example of that would be angle 1 and angle 5. If you notice that angle 1 and angle 5, they both are the same degree. If we knew the actual degree, we could write it down. We know they're the large angle. Angle 1 and angle 5 are the same size. You could trace angle 5 and slide that up, and the tracing paper would match exactly with angle 1. They're also orientated the same way. Basically, that means they are turned or facing the same direction. So 1 and 5 is an example. Another example would be angle 2 and 6. 3 and 7 are also corresponding angles. And also 4 and 8 are corresponding angles. All right. Name a pair of alternate exterior angles. All right, so we need to talk about alternate. The first part of this relationship, you're going to have one of two things. You're going to have the word alternate, or you're going to have the words same side. And they're referring to the transversal line. Let's see if I can draw that straight here. So here's our transversal, and basically you have like side A and B. You have two different sides. If it says alternate, then they're going to have to be, the angles are going to have to be on opposite sides. The exterior refers to where the angles are at according to the parallels. So anything in here would be interior. Anything outside of that would be the exterior. And you can think of this like a house. If this was the floor and this was the ceiling, anything in here would be interior, would be the interior of the house. Anything above or below that would be exterior. Obviously, if this was a house, the exterior right here below would be like the dirt, and above would be the air and the clouds and anything above the roof of the house, okay? So exterior, interior. So when it talks about alternate exterior angles, so alternate, if we're looking at number 1, the matching alternate angle would have to come from side B, because we already got something from side A. So for alternate, we got to come to side B. And the alternate exterior angle would be 1 and 8. They have to be the same size, and they are the same size angle. They have to be on alternate sides of the transversal, and they have to be in the exterior. So one pair would be 1 and 8. A second pair would be angles 2 and 7. They would also be alternate exterior angles. All right. Number 3, name the relationship between angle 3 and angle 6. So angle 3 and angle 6. So we're looking at these two pieces. All right, they are on alternate sides of the transversal, so they're going to start with the word alternate. All right, and you can see that they're both on the interior. So these are alternate interior angles. Okay. Just a note here, they are congruent, meaning they match. And I think we just talked about that they matched. So I'm just going to put a little note here that they're congruent. They match, they're the same. So maybe you want to put same size. I don't know if you can see that back there. I'm trying to make the marker right a little clearer. Same size. All right, number 4. Name the relationship between angle 4 and angle 6. 4 and 6. All right, so let's take a look. 4 and angle 6. All right, they seem to both be from this right-hand side. So they're not alternates, they're same side. So we're going to start off with same side. And they're both in the interior. So same side interior angles. All right, and if you look, I'd like you to look and see if they're the same size, okay? And if you look closely, you'll notice that angle 6 is much more closed in than angle 4. They are not the same size. These are what we would refer to as supplementary angles. And supplementary angles add up to 180. 180 degrees together. So if you add them together, these have to equal 180 when you put them together. All right? Problem number 5. We're asked to look at these relationships here and say whether they are congruent or supplementary. So congruent means exactly the same. Supplementary, you remember, means 180 degrees when added together. So number 5, alternate interior angles. So it may help if we go ahead and we make an example for each one of these. So alternate interior angles. So that would be an example like 3 and 6. Those would be alternate interior. So 3 and 6 could be our example. And it's asking you, are they the same? Are 3 and 6 congruent to each other? Do they match? And the answer is yes, they are congruent. They are the same size. Number 6, a linear pair. We've talked about linear a lot in our core bites. And those first 4 letters spell line. Some people even say linear to help remember that it is a straight line. And if you remember, a straight line has 180 degrees in it. So this is a pair of angles that share a side and are 180 degrees together. So let's look at some examples. We could look at angles 7 and 8. That is a linear pair. Notice how when you put 7 and 8 together, they form a straight line across the top. Okay, they share a side, so that's a linear pair. Let's look at another example. There's many examples up here. We could look at 5 and 7. 5 and 7 are on the transversal line. All right, together they make 180 degrees because this line is straight. They do share a wall. So we'll write down our first example, 7 and 8. They are supplementary. They are not the same size. Okay, so they add together to make 180 degrees. They have to share a side. That is called adjacent. So I'm going to write that right here. They are adjacent. So they share a side. Some people say a wall. They share a side or a wall. All right, let's see. What else can we talk about? Let's see. They share a side. They're supplementary. They're 180. Let's put an example down here so that we have it for later. So here's an example, A and B, and you can write, they add together to make 180 degrees. So they add together to make 180 degrees, and they have to share a side. All right, number 7, corresponding angles. Talked about that right up here, number 1. They have to be congruent, and they have to have orientation. So once again, we could just use angles 1 and 5 as our example. And are they congruent? Are they the same, 1 and 5? Yes, they're absolutely congruent. So at this point, you may be saying, well, why is that important? Well, that's important because if I tell you angle 1 is 140 degrees, that means that you would know that angle 5 is also 140 degrees because they're congruent. So that gives you some information that you can use to solve. All right, number 8, same side interior angles. All right, same side interior. We could use 4 and 6 as an example. 4 and 6. All right. They are not the same size angle. One of them's much tighter, one of them's much more open. So these are not congruent, these are supplementary. Remember, that means they add together to be 180 degrees. All right, and the major difference between same side interior and linear pair is that linear pairs have to be side by side. They have to share a wall, like A and B do right here. If we look at angles 4 and 6, they do not share a common wall. Okay? They do add together to be 180, but they don't share a side. So that's the major difference between linear pair and same side interior angles. We do know that they add together to be 180. So if I was to tell you that angle 4 is 100 degrees, then you would know, okay, well 4 and 6 make 180 together. So if you did 180 and you took away the 100 that you do know, the 80 that's left over would have to be angle 6, because together these two have to be 180 together, combined. So that's useful information, once again, when you're solving problems. All right, number 9, vertical angles. These are often referred to as bow tie angles or kissing angles. They're straight across from each other, and they have to share a common vertex. So, like, examples would be angle 7 and angle 6. If you notice, they share that point right there in the middle. That's how they get that name, kissing angles. If I connect these, they start to look like a bow tie. That's where they get that name, bow tie angles. They're congruent. They match each other. So if you know one of them, you actually know both of them. So I'm going to use 6 and 7 as my example for that. And they are congruent. So if I told you that angle 7 right here was 65 degrees, guess how much angle 6 has to be? That's right, 65 degrees. So that would help me solve any of the problems I may have. If this one's 65, so is this one. If angle 6 is 65, so is angle 7. Number 10, alternate exterior angles. Alternate exterior. That would be like angle 1 and angle 8. Those are alternate exterior. So 1 and 8 can be my examples, and they are congruent. They are the same. All right. Moving on. So problem 11. All right, let's talk about how to read that. So here's what it's saying. It said, what is the measure of angle 2 when the measure of angle 1 is 30 degrees? All right, so they've given us some information. They've told us what angle 1 is equal to, 30 degrees. So we now have to figure out what angle 2 is. And if you'll remember from the relations we had just a little while ago, that 1 and 2 would be considered a linear pair. That is their angle relationship, linear pair, because they form this straight line going across the bottom, and they share a side right here. So that's what makes them a linear pair. And we know that that's 180 degrees together. If angle 1 is 30, we simply subtract to find angle 2. And we find out that angle 2 is 150 degrees. So we now have the answer. Measure of angle 2 equals 150 degrees. All right. Number 12, the measure of angle 6 when the measure of angle 1 is 30. So they haven't changed anything. What that tips us off is that we can go ahead and fill in the rest of this, because they're not changing it. Sometimes you're going to have problems where they change it every single question. Okay, so be careful with that. This one doesn't. We can see that 1 is still 30. We can see that later on in the problem that angle 3 is 150. Well, let's check to see if that is the case for us. We know that 2 and 3 are vertical angles, so they should match, and we know that 150, 150, that does match up. So that tells us we can fill in the rest of this graph or chart here. This parallel lines cut by the transversal. And it means that all of the large angles, like 2 and 3, are going to be 150 degrees. The other ones, the other congruent angles would be 150 on angle 6 and 150 degrees on angle 7. And they will form a zigzag. I'm going to clean this up just a little bit. It might be easier for you to view it. So 150 on all of these large angles. All right. And we know that angle 1 was 30 degrees. And we now know that all of the smaller angles are 30 degrees. So now it should be pretty simple to fill in what they're asking. So what is the measure of angle 6? We can look over here and see it was 150 degrees. The measure of angle 7, also 150 degrees. All right. And 14 applies to this right here. So ready to move on. All right, so problem 14, measure of angle, so that's what it's saying, measure of angle EGB. So we got to connect those letters, so E to G to B. So it wants to know the measurement of that angle right there. It says 4x. That's not an actual measurement. That's just an algebraic expression. So we've got to figure out what other pieces in here can we use to actually solve and find all the measurements for this. Well, we know that 4x is given to us, and we know that they gave us this piece right here, okay? So how can we use this information? Well, these look to be the same size angles. And if you think about it, these are alternate exterior angles. And if you look back to your alternate exterior angles, you'll see that they are congruent. They match each other. If they told us that this angle was 140 degrees, then that means that this would be 140 degrees. So they would be equal to each other. That's the information we need to use. They are equal to each other. So that means that 4x is equal to 2x plus 50. And it's a one-step equation, or sorry, it's a two-step equation that we have to solve. We have variables on both sides, so we need to get the variables to the same side. You could start by subtracting 4x from both sides. You would end up with a 0 over here and a negative on the right-hand side. I would try and avoid that. So it may be better for us to subtract 2x's from both sides. 4x, take away 2x's, leaves you with 2x's. 2x, take away 2x, that's like having 2 apples and somebody taking 2 apples away. How many apples do you have left? None. So those two cancel each other out, they're gone. But this 50 just comes down. We didn't do anything to the 50, so it comes down. Now we have a one-step equation. That's 2 times x equals 50, so you got to use inverse operation, which means to divide, because it's the opposite of multiplying. 2 divided by 2 makes 1x, or just simply x. It's an understood 1. 50 divided by 2 is 25. So we have x equals 25, and many people think they're done right there. They write 25 down, but it's incorrect, because all you found was x. So you've got to go back to your original problem and plug 25 in for x. In this case, it's 4 times x, or 4 times 25, which tells us that the answer is 100 degrees. All right, problem number 15, angle AGH. AGH. All right, so A to G to H. So they're asking about this angle right here in red. Well, what do we know about these two? They are what type of angle, what type of relationship? You may be saying congruent. You're right, they're congruent. And the actual angle relationship name is they're vertical angles. They are congruent, they do match. So that would mean that this is 100 degrees. If this one's 100, so is this one. So the measure of AGH is 100 degrees. All right, last problem. It says DHF. DHF, that's right here in green. Well, we need to use a little bit of the knowledge we already have. We talked about that this angle was equal to this angle. They're alternate exterior. So if this up here was 100, so is this. And now we can use the information about linear pairs. So these two right here form a straight line, and the only way they can do that is if they add up to a certain amount. How much is the value of a straight line? It's 180 degrees. This is a linear pair. So if together they're 100, and this piece right here is worth 100 by itself, so that's just 180, take away 100, And what do you have left? That's right, 80 degrees. So this missing piece right here, we now know is 80 degrees.